You know, when we look up at the night sky, we think of stars, planets, the final frontier. But what if I told you we've also created the universe's highest and fastest landfill right over our heads? Today, we're going to dig into the massive problem of space junk.
So how did we even get here? Well, our journey to creating this giant cosmic landfill, it actually starts right at the beginning of our journey into space. It turns out, we left more than just a flag up there.
That's right. Those iconic first steps on the moon, they were also our very first act of, well, interplanetary littering. Neil Armstrong and Buzz Aldrin left behind some stuff that's surprisingly ordinary and personal.
I mean, check this out. It's a pretty mundane list for such a huge problem, right? Boots, tools, and, yeah, you're reading that correctly, vomit bags. It seems like from the very start, we just had this habit of leaving things behind.
And what started with a few things on the moon just escalated. For decades, the problem grew from these simple, almost clumsy accidents. A lost camera here, a dropped tool bag there. But the whole game changed in 2009. A single satellite collision didn't just add 1 or 2 pieces of junk. Oh no, it created thousands of tiny, high-speed bullets.
So just how bad is it really? Well, this collection of cosmic cast-offs has literally transformed the space around our planet into a high-speed minefield.
The scale of this is it's almost impossible to wrap your head around. We are talking about over 131 million individual pieces of junk circling our planet right now. To put that in perspective, that is a bigger number than all the households in the entire United States. This isn't just a small problem, it is a swarm.
And it's not just the number of pieces, it's the insane speed they're traveling at. This stuff is moving at about 10 kilometers per second. That's 22,000 miles per hour. At that velocity, something as tiny as a fleck of paint can hit with the destructive force of a bowling ball. Now, okay, a lot of those 131 million pieces are super tiny, but over 1 million of them are at least 1 centimeter across. And that is more than big enough to completely destroy or cripple the satellites our modern lives depend on for, everything from your GPS to weather forecasts. Remember that 2009 collision we were just talking about? This is what makes it so absolutely terrifying. One crash between 2 satellites didn't just, get rid of them. It created a cloud of thousands of new projectiles, and every single one of those is capable of causing another collision. It is a chain reaction just waiting to happen. And believe it or not, that chain reaction has a name: the Kessler Syndrome. It's the absolute nightmare scenario where the debris field gets so dense that it just triggers this runaway cascade of collisions. This could destroy pretty much all of our orbiting spacecraft, effectively trapping us here on Earth and slamming the brakes on the space age for generations.
I know, this all sounds like some distant science fiction problem, but you're probably wondering, okay, what does this actually mean for me down here on the ground?
The first question that pops into most people's minds is pretty direct. Could this stuff, fall on me? And while that thought is pretty alarming, let's take a look at the actual risk.
So, here's the good news. The probability of you personally getting hit is incredibly small, because most of this junk just burns up harmlessly in the atmosphere. But, and this is a big but, some larger pieces do survive. For example, a big chunk of a SpaceX capsule slammed into an Australian sheep farm back in 2022. And as the amount of junk up there goes up, so do the odds of another piece making it all the way down.
So yeah, the problem is real and it's getting worse, but it is not hopeless. Scientists and engineers are tackling this head-on with some truly innovative ideas for both preventing more junk and cleaning up what's there.
The strategy is basically two-pronged. First, and this is a big one, we have to stop making the mess worse. And second, we need to figure out how to clean up the junk that's already threatening those orbital highways.
So on the prevention side, we're actually getting a lot smarter. We're packing more than 100 satellites into a single launch to cut down on the number of disposable rockets. And get this, we're developing servicer satellites. They're basically robotic mechanics that can refuel and repair existing satellites to make them last longer.
Now for the cleanup. One of the most practical methods is something called controlled re-entry. Think of it like a planned retirement. Engineers use a satellite's last little bit of fuel to steer it down into the atmosphere where it safely burns up over an ocean or some other empty part of the world.
And then there are the solutions that sound like they're straight out of science fiction. Seriously, we are talking about giant, ground-based lasers that can literally nudge debris off a collision course. And even space tugboats, designed to go up there, grab huge pieces of junk, and just tow them away. How cool is that?
You know, when you take a step back and look at the whole picture, this entire issue really forces us to do some reflecting. The mess we've made up there in orbit, it's more than just a technical problem. It's kind of like a mirror.
This quote from our source it really hits the nail on the head. Our orbit has become a direct reflection of how we consume and dispose of things right here on the ground. It's this physical manifestation of our whole out of sight, out of mind approach to waste.
So in the end, this final frontier is a shared resource, just like our oceans and our atmosphere. And the challenge of cleaning it up forces us to ask a much bigger question. If we want to keep exploring the cosmos, how are we going to learn to clean up after ourselves, both up there and down here?